All right, now we're going to be looking at what are called compound inequalities with an introduction and a couple of solved examples. Compound inequalities differ from simpler inequalities because they have two inequalities sort of merged together into one compound statement. And let's look at a couple examples here. So for this first one, you'll see the graph here. We're looking at this example right here. You'll see the graph where the red shows the possible values of x or of our variable. Okay, so it looks like x could be a -3, x could be, there's the -3, whoops. X could be the -3, x could be a +2, and x could be anywhere in between. And so we can write this as a compound inequality like so here. -3 is less than or equal to x, which is less than or equal to 2. So I call this a between inequality or an and inequality, meaning x is between -3 and 2 inclusive. And the and part means that x has to be larger than -3 and less than 2 inclusive. And that contrasts with these or inequalities, what I also call beyond inequalities. So this graph down here, I call it a beyond or an or inequality, where x can be less than or equal to -1, and that's talking about this part of the graph right here. X can be less than or equal to -1 or greater than or equal to 4. And you notice that I use the word or in between those two statements. And so we would write this as x is less than or equal to -1 or x is greater than or equal to 4. Okay, so those are examples of compound inequalities. So writing and graphing them, we'll do a couple more examples like I just showed you. So this example looks like an and or a between inequality. X goes from -2 to 5. And often I just like to write the boundaries or the edges first with an x in the middle. And then it looks like x has to be greater than -2, which means -2 is less than x. So just to be clear, this is a less than symbol, okay? But we could also think of that as saying that x has to be larger than -2, okay? And then x has to be less than or equal to, and that's not a -5, that was my mistake, that's a +5. X has to be less than or equal to 5. So this would be a solution right here of translating that graph into a compound inequality. This next one, it looks like x has to be less than or equal to -5, or x has to be greater than -1, okay? And that's an or statement or a beyond inequality, I sometimes call it that. And the last one, we're given a compound inequality and let's turn it into a graph. So I'll draw out a number line here, and looks like I need some numbers maybe from a -1, 0, 1, 2, 3. You can scale your number around the line however you like, as long as you're consistent with it, and I like to just place the numbers a little bit beyond the numbers given in the statement. So it looks like -0.5 is less than x, so that's an open circle at -0.5. We have a closed circle at 2. And this is a between inequality. X is between those, and so we can fill in between, right, like that. When we're working with compound inequalities, we can also solve them as well. And this is just like we've been solving inequalities before or equations before. We need to do the same thing to both sides, or in this case, there's actually 3 sides that we need to do the same thing to. And always remember the rule regarding negatives. If you're multiplying or dividing by a negative, you need to flip the inequality symbol. Although peering ahead at this one we're about to do, it doesn't look like we'll have to multiply or divide by a negative. I'm seeing that +3 times m, and that makes things a little bit easier. But let's add 2 to both sides, or in fact all 3 sides. Okay, and then let's see what that cancels out. That cancels out this 2 right here which means the 3m comes down, the signs come down. Negative 8 plus 2 is a negative 6, and 11 plus 2 is 13. So we can do our final step of dividing everything through by 3. Negative 6 divided by 3 is a negative 2, is less than or equal to m, is less than, I'm going to keep it as an improper fraction as 13/3. Okay, or just over 4. And that would be my final answer right there, solving that inequality. Keep in mind though, if you were to see a problem where you had to divide or multiply by a negative 3, you would need to flip both of the inequality symbols. So for example, if this was a negative 3 right here, I'm putting something in right there, and we had to end up dividing by that negative 3, this symbol would flip and that symbol would flip. And then you would have to think carefully, does that turn into an or, a beyond inequality, or does it stay as an and, a between inequality? Just getting rid of that negative. Okay. And here's another one that we'll solve. We have 7 is less than or equal to negative m plus 2, or 3m is greater than 12. So it's a beyond inequality, looks like. And we can subtract 2 from both sides here, and we can also divide 3 from both sides here. So we're treating these two statements separately. Unlike the prior one we just did, when we subtract 2 here, we don't have to subtract 2 from over here. Okay, we're just subtracting 2 from that piece of the inequality. Okay, so this turns into a 5 is less than or equal to negative m, or m is greater than 4. So that one is finished. This first one we need to divide by a negative 1, which means we'll end up flipping some signs. So we have a negative 5 over here, and that less than or equal to turns into a greater than or equal to. Okay, so let's take a look at what we have right now. We have two basically greater than statements with an or in between. Okay, so or really means that one or the other has to be met. They don't have to both be met. Okay, so actually I take that back. Yes, I was thinking about that incorrectly right there. Okay, so and that my misconception was because this m over here was on the right hand side. So I want to rewrite that inequality with the m on the left. Okay, and we'll flip that whole thing around, and sorry about that. We'll make our final statement here. M is less than or equal to negative 5, or m is greater than 4. So forget what I said about the or statement earlier, but now we have a correct solution here. Let's do a quick number line sketch here, just to show you, just to model that. We have a negative 5, negative 4, negative 3, negative 2, 1, 0, 1, 2, 3, 4, 5. Okay, so just real quick here. M is less than or equal to negative 5, or m is greater than 4. Okay, so any of those numbers in there within the red zone need to be met. Okay. Graphs versus interval notation. So a little bit of new information here that I want to give you. So the three statements you're seeing right here are written in inequality notation. And we've shown some graphs before. I'll do one of these as a graph just to remind you, or just to reinforce this idea of what we're working with. And x has to be greater than or equal to 2, so 2 is allowed, 2 is in our solution zone, and it has to be larger than or equal to that. Okay, so that's an example of a graph. Interval notation is often much shorter to write our solutions as when we're dealing with inequalities. So let me show you that as well. So if x has to be bigger than or equal to 2, we can write our answer like this. That means x can be anywhere from 2 all the way up to infinity. And this means that 2 can be included here, that square bracket, and the curved parentheses means excluded, because you can never actually reach infinity. So x cannot actually be infinity. Infinity is not a number. But x can include 2 anywhere up to infinity. This works well, particularly well for the for compound inequalities. And I actually want to change this inequality right here to be a less than. So I changed that second one right there. Interval notation is really easy here. -1 is less than x is less than or equal to 3. So since 3 is included, we get a square bracket. -1 is excluded. It gets a curved bracket right there. And for the or sort of compound inequalities, x is less than 5. So x can go from -infinity up to 5, including the 5. Oops, not including the 5. Or x can go from a 9, including the 9, up to a positive infinity right there. Okay, so that's an example of interval notation. Often it's a little bit easier to write that out than to write out all your inequality symbols. That's a good place to stop right there.